Welcome to Brain Vision.
For this question, we're asked to plot the wave function psi1s as a function of the radius r, as well as the probability density p1s as a function of the radius r. So I wrote out those equations here. So to plot them, the easiest way is just to simply plug them into some kind of plotting program. I just used a graphing calculator. So the first one we can look at is psi as a function of r. So we'll plot psi on the y-axis and on the x-axis and r on the y-axis. The uppermost point for r is approximately 1.5. And the bottom point is 0. The bottom point for psi is also 0, and the rightmost point is at about 1. And it decreases as a function of the exponential from the negative sign, and it looks something like this. And then when r is 0, psi is 0. Next, we want to plot the probability density as a function of r. So we'll put p on the x-axis. Once again, put r on the y-axis. We'll start it again at around 1.5 for a similarity comparison. And the rightmost point at r happens when r is equal to 1. So that's another important point. The largest value of p is a little bit larger than 0.5. It's between 0.5 and 0.6. So we'll put 0.5 down. And it looks like this. So it goes over. At about 1 is where it turns back. And it comes in. And then it ends at both r and p equal to 0. So it crosses right there. I'll try to make that look a little more correct. There we go. So it doesn't ask us to make any statements. It just asks us to plot these out. But clearly, both the wave function and the probability density are radially dependent. So we can just say from these graphs, there we go, we can see that the wave function and the probability density are both radially dependent. Radially meaning r. And the graphs, as well as that statement, are the solution to our question.